All right, so this week we're going to take a look at two formulas called the Law of Sines and the Law of Cosines. And as I said, they're basically used to figure out angles in triangles and sides. Right? So that's going to be the goal. We're going to be finding sides, we're going to be finding angles. As I said, we did it before. Okay, but the kind of triangles that we always did it with had a 90, which makes them a right triangle. Well, if none of the angles in the triangle are 90, then you have what's called an oblique triangle. So every triangle we solve, pretty much every triangle we solve this week is oblique. Now, if I happen to give you a problem that has a 90-degree angle in it, you can go back to what we learned last week. Solve the whole problem that way. The stuff that I'm teaching you, though, will work on anything. You can use this stuff on triangles that have 90s. You can use it on triangles that don't have 90s. Okay? But if you really like Pythagorean theorem and the SOHCAHTOA stuff better, if you have a 90-degree angle, you can go ahead and use it. Okay? But the focus this week is mostly going to be on triangles that don't have a 90. So, under oblique, there's really two different types of triangles. We're not really sketching things to scale, so it doesn't really matter too much. But the idea is you can have a triangle where all the angles are less than 90. Think of like an equilateral triangle. Okay? All the angles would be 60, 60, 60. Okay, so that's an example of a triangle with no 90s. Or you could have an obtuse triangle. That's a triangle with one angle bigger than 90. Can you have more than one angle in a triangle bigger than 90? No? Kayla, how come?
Because then they'll add up to more than 180. Right,
they would add up to more than 180. So if you had two angles bigger than 90, it's already too big. So you can never have two angles bigger than 90 in a triangle. Right? I generally sketch every problem as an obtuse triangle. Again, the sketch doesn't have to be to scale. That's just how I do it. So we're going to set up a diagram for solving triangles. We're going to name the sides using certain letters. We're going to name the angles using certain letters. Did anyone remember last week the letters we always used for the sides? Or actually it was 2 weeks ago. We use certain letters for the sides and then other letters for the angles. You want to remember, Ben, you remember the sides? Do you remember just even in geometry how you normally label the sides? Think of like a right triangle.
ABC.
ABC. So we use the English letters ABC for the sides. And then we used A, or we used alpha across from A, and we used beta across from B. But now we need one more name. Okay? Because the angle that used to be 90 isn't 90 anymore. Since it's not 90, we got to call it something. Okay, so you still have ABC, you still have alpha across from A, still have beta across from B, but now we have this Greek letter. Kind of looks like a bird flying into the sunset. Does anybody know what that letter is called? Good guess, not omega. Omega looks kind of like that. That's a lowercase omega anyway. Capital omega looks kind of like looks different. Anyone else know what that letter is called? That one's gamma. That's G-A-M-M-A, gamma. And it looks kind of like a Y. I don't know. That's what it looks like. So almost like a capital Y, kind of, but not. It's a little different. All right. So we got our diagram, and every problem I give you, I'm always going to give you 3 out of the 6 things. Okay. Which 3 out of the 6 things I give you in that diagram, that's going to control whether you use the law of sines or the law of cosines. So I'm going to show you the kind of information I'm going to give you today. Okay? And this is going to be for law of sines, because that's the title, law of sines. So if you are given 2 angles and a side, that is a problem where you always use law of sines. Now, even if you're given two angles and a side, there's actually a couple of different ways I can even just do that. I can give you two angles and the side that's between them, or I can give you two angles and the side that's not between them. Okay? Either way. And here's a picture of each situation. The one on the left, you've got two angles, and you've got the side that connects them. Okay, the one on the right, you've got the two angles. Now the side that connects them is the one on the bottom. You don't have that one this time. You've got one of the other sides, the one of the two sides that does not connect the angles. But either way, if you're given kind of the situation on the left or the one on the right, they both fall under the law of sines. Any question on the difference between those two situations? Okay. Now the third situation is a little different. That's when you're given two sides and an angle. Specifically, you have to be given the information like that. The two sides and the angle that is not between them. Okay? So if you're like, what do I mean by the angle between them? Here's a side you know. Here's another side you know. The angle between them, where the sides meet, is right here. If you were given that, that's a problem for what we're learning Monday and Tuesday. That wouldn't work. Okay? That's something we're going to learn on Wednesday. Okay? So for now, if you are given two sides, you always have to be given the angle that is not where they meet. That means I could give you this one, or I could give you that one. Either one is fine, but not the one where they meet. Okay? And this one we're going to do a little bit with today, and then we're going to spend most of tomorrow on that one as well. Okay? Because that one can be a little tricky. The first two, no, those aren't too bad. But the second one's a little tricky. So, to solve any of the types of problems I just gave you, law of sines. Okay, and we're going to go through what that formula is. It's really based on right triangles. Okay, that's where the formula comes from. If you see me write the abbreviation LOS, that just means law of sines. Okay. All right, so let me just draw a triangle. You don't need to label all the sides because I'm not using all the sides. I'm not going to use side C, and I'm not going to use angle gamma. I mean, you can label them if you want, but you don't need to. Okay, and I tried to make that triangle look stable. Okay, it's nothing special about it. All the sides are different. All the angles are different. All right, now what you want to do is draw in the height. So the height goes from a vertex perpendicular to the other side. Now I could have done that anywhere. I could have drawn in a line from the vertex perpendicular to the other side, but I chose to do that one. Now, what did I just create by putting in the height? I created something, yeah?
Two right triangles.
I created two right triangles. We're going to kind of look at the one on the left first, then we're going to look at the one on the right. Now, I'm going to call this H for height. Not for hypotenuse, don't get it confused with that. But H means the height of the triangle. Okay. Any questions before I block the right triangle, the triangle that's on the right side? Okay, so let's just look at the triangle that's on the left. Okay, what I want to do is I want to come up with a formula for H. Okay, I want to find a formula for that height. Okay, and I want to use two things to do it. This and that. And we're going to come up with a formula for that. So this part's going to be kind of like what we did a couple weeks ago. So look at this angle. Okay, what's the name of this angle again? Alpha. Okay. If you were standing at alpha, what do you call the side that's farthest away? We've labeled it H, but what do we call it? Well, it could have a different name, but what's its position relative to standing right here? It's the side that's farthest away, yeah? It's opposite. So you can call the side whatever you want, but its position is opposite the angle. And what about B? That's across from a 90. So what do you always call the side that's across from 90?
Hypotenuse.
Hypotenuse. Yep. So in that diagram, the two sides, the two positions of the sides you're looking at are the opposite side, which is named H, and the hypotenuse, which is named B. Now, what trig function involves these two sides? It's either sine, cosine, or tangent. What is it? Yep, it's sine. So I'm going to write down sine of my angle equals, now fill in the other side, opposite over hypotenuse. Opposite, we named H, hypotenuse, we named B. Now, my goal, I said, is I want H by itself. So how would I move the B to the other side? What would you do? You would multiply both sides by B. Times B, times B, and there you go. Now you've got H by itself on the right, and you've got a formula. So the formula to find the height of the triangle on the left, you got to know two things. You got to know the angle, and you got to know B. And if you know both of those, fill them in, and you can find the height. Questions on that? Okay, I'm just going to call this box 1, because we're going to come up with a box 2. Okay, but that's box 1. Okay. Now, let's look at the triangle on the left. I want to do pretty much the same thing again. I want to find a formula for the height, but this time I want to use the two things that are in the triangle on the right. I want to use this and that. So go through the same set of questions again. We're going to see kind of the same thing happen. The side that we've labeled H, what's its position? This time from the perspective of beta. Oh, Jose?
No.
You're not sure? Well, it's the one that's farthest away. Do you remember what we call the one that's farthest away? Remember what we did on the other one?
No.
No. Yep.
Opposite.
Opposite. Okay, so the one that's farthest away, that's the opposite. And then A, its position, it's across from the 90. So what do we always call that one? Hypotenuse. So the names of the sides are a little different, and the name of the angle is different, but the position is exactly the same as the other one. We're using opposite and hypotenuse. So what trig function is that? Jasmine?
Sine.
Sine. So we're going to set up another equation for the height using sine. So let's start with sine. And Madeline, what would it be? The sine of, what do we always put there?
I don't know.
Do you remember what we did on the last one? What did we do on the left side?
I don't know.
You want to help her out? What would we on the left one, Aaron?
Sine theta.
Yeah, so on the left side we just did sine of alpha. On the right side we're going to do sine of beta. Equals. And what's going to be my fraction?
H over N.
H over A. Yes. Why'd you do that? It's opposite over hypotenuse, and that's the definition. That's what you plug in. So h over a. Now I want to get h by itself. So just like we did on the left, what would you do here to get h by itself? Good. Multiply by a. Multiply by a. So what am I going to put in? We're going to call that box 2. What's going to go in that box? Oh, Peter? It's going to go in that box.
Isn't it a sine?
Yeah, keep going.
And
Do you remember the name of that Greek letter?
a
Not theta. It begins with the same, it begins with the letter that it kind of looks like. Kind of looks like a B, right?
oh, beta?
Beta. So, yep. So you're going to put A sine beta. So now we have a formula to find the height again. But it's not the same formula we had on the left. So box 1 is a formula that gives you the height. So is box 2. What does that mean?
It just depends on what you're given.
Okay, so it depends on what you're given. What else does that mean? There's like another fact you could infer here. It's what? So box 1 gives you the height, box 2 gives you the height. There's a kind of another fact that you could interpret from that. I'm going to be at the concert on Saturday. John's going to be at the concert on Saturday. What is that? What else does that? What does that mean? Like, what's the third thing you could kind of say there? I'm going to be there. John's going to be there. We're both there, right? So yeah, we're both going to be there because I'm there. He's there. Box 1 is equal to the height. Box 2 is equal to the height. So what does that mean? What's the third thing you could say? They're both equal to the height, which means what? If they're both equal to the height, they're both equal to the same thing. What does that mean?
They're the same.
They're the same, right? Box 1 and box 2 are the same. They are equal to each other, right? You could think of it another way. I have the same amount of money as Sarah, and John has the same amount of money as Sarah. They each have the same amount of money as someone else. Then that must mean they each have the same amount of money as each other. They both have the same amount of money. Right? So box 1 and box 2 are equal to each other. So let's write that down. Box 1 and box 2 are exactly the same. They're different formulas, but they will give you the same result. They both give you the height. So B sine alpha equals A sine beta. Now, that's pretty much the law of sines. The only thing they usually do is they put all the A's on the same side as alpha and put the B on the same side as beta. So how could you move the A over to the other side with alpha? Yep. And how could you move the B over to the other side with beta? Divide it. So let's divide each side by A. That'll cancel out the A's there. And at the same time, let's divide both sides by B. That'll cancel out the B's there. So now what you're left with is sine of alpha in the top, and you're left with A in the bottom. Equals, you have sine of beta in the top, and you have B in the bottom. Now, there's a third part to the law of sines, and this part we didn't really prove, but I'm hoping you can figure it out based on the pattern. Does anyone have a guess what the third fraction is going to be?
Is it gonna be something or more like on Wednesday?
No, it's going to be just basically continuing the pattern you see right there. So you've got sine of alpha over A, sine beta over B,
Is it gonna be sine gamma over C?
sine gamma over C. Yep, that's the third part. We didn't prove that. Okay, we just based it off the pattern we were seeing. I could prove it. We would do the exact same thing we just did all over again, except instead of labeling sides A and B and alpha and beta, draw the height in from a different side and then go through the problem. Okay? But I'm not going to do that same thing all over again. So really, just by separating it into two right triangles, getting a formula from one and another formula from the other, and realizing they're the same thing, that gives you the law of sines. Okay. So I think, yeah. So that is the law of sines right there. Now, I consider that to have three parts. Each fraction is its own part. You never use all three parts at the same time. Okay? You only use two at a time. So either the first two parts, the last two parts, or the first part and the last part. So when you use it, you're basically going to have something like this. You're going to use two parts of it. You're going to have a fraction on the left, a fraction on the right. You have four spots. 1, 2, 3, 4. 3 out of 4 of those spots are going to be numbers. One of them will have a letter. What do you call this kind of thing? Like if I said to solve for x there. Anyone remember what this is called? When you have a fraction equal a fraction? Begins with a P. A proportion, yes. So the law of sines, basically every single problem you do is going to be setting up a proportion. And how do you solve a proportion? What do you have to do? Yes, you have to cross multiply. And that's what you're going to do every single problem with law of sines. Cross multiply. Okay, so to kind of organize all our information, we're going to make a sketch because that just makes it, I think, to visualize what's going on, makes it easier. And then you're going to put all your data in a table. Same table we did 2 weeks ago. You're going to do 3 sides in one column, 3 angles in the other. Now, you can no longer use Pythagorean theorem. Because remember, Pythagorean theorem assumes you have a 90. You might not. In fact, most of the time you won't. You also can't use SOHCAHTOA, okay? Because that means you have hypotenuse. We're not going to have a hypotenuse in most problems. So the only thing you can use is the new formula we came up with. Okay, right? What I'm pointing to. You can still use the fact that all the angles in a triangle add up to 180. That doesn't change. So you can definitely still use that. Okay, so goal is what we're going to do is look at 3 problems. One of each type that I had on the board, right here. Okay, we'll do an angle, side angle, a side angle angle, and then we'll do one of the asterisk type, okay, the side angle. Okay, so I said to you, every problem I do with you, I got to give you 3 pieces of information. Okay, so out of the 6 things in the triangle, there's 3 of them right there. Alpha is 40, beta is 60, A is 4. So you can set up a table if you want first, but eventually you got to make a sketch because you want to figure out, is this a law of sines problem or is it law of cosines? And the easiest way to figure that out for some people is to make a sketch. Okay, so I got my 3 sides on the left, got my 3 angles on the right. I put a box around everything that I need to find. Okay, but before I find anything, let's just draw it out. I'm going to put A over here. What angle always goes across from A?
Alpha.
Alpha. You can put A anywhere you want in that picture. As long as once you pick a spot for A, you put alpha across from it. Okay, so across for me means over here. A alpha. Let's call this side B. And what angle always goes across from B?
Beta.
Beta. So B, I put it on the bottom. And across for me means up at the top. Now I don't have any choices left. C has to be the third side, and gamma has to be the third angle. So look at the information you're given. Got the 40, the 60, and the 4. What I want to know now is which of the 3 types it is. Is it this type? Is it that type? Or is it that type? So we'll go back and look at where the information is. So it's not only what information they gave you, it's where is it? What kind of triangle is this one?
Side angle.
Yep, you've got a side, an angle, and an angle. So you could write, some people write angle, angle, side. Some people write side, angle, angle. The same. The point is you've got 2 angles and the side that's not connecting them. Okay? If you go back and look at your notes, that's a law of sines problem. Okay? If I gave you a problem right now that wasn't one of the 3 types I just described in the notes, you'd be stuck. Because it would be law of cosines, and we don't know that yet. So every problem that I give you Monday and Tuesday, it will be law of sines. On the test, they'll just be mixed up. You'll probably have 3 law of sines problems and 3 law of cosine problems. But even though there's only 3 problems, each question has 3 answers. So really it's like there's 18 answers on the test. Right? This would count as 3 separate questions on the test. And you get points for each one you get right. Okay, so there's a lot of room for partial credit. Okay. Anybody see something you can find here first pretty easily? You don't really even need law of sines. You could have found this without anything I taught you so far. Yep.
B equals 6.
This angle is 6?
Yeah.
How do you...
Or the size. I don't know, I just saw the pattern 4 equals 40.
Oh, you're just thinking maybe like if you divide that by 10, you get 4. If you divide that by 10, you get 6. All right, so it's good you noticed a pattern. Unfortunately, that doesn't work.
Yeah.
But it's always good to notice patterns. It just doesn't work here. Anyone see anything else that you can find? Pretty easy?
Is gamma 80?
Yes. How do you know that?
Because all 3 of them together equal 180.
Yes. All the angles have to add up to 180. So that means this angle has to be 80. Now, before I write it in, I just want you to look at your table. The 3 things I have there right now were given. And look at this. You have a row that has everything in it. It's the only row with everything in it. Row 2 is missing something. Row 3 is missing everything. So you have a row that has everything in it. That's another way you can tell it's a law of sines problem. Okay? So making a sketch can tell you, or if you look at your table and you have a full row, that's another way to tell that it's law of sines. If you're wondering, well, how could you have a problem that's not a full row? Well, let's say I gave you a side, and a side. SSS. You wouldn't have a full row. You have a full column. But if you don't have a full row, law of sines isn't going to work. That would be something else. Okay. So let's put that in right there.
So that's supposed to be
80. 80, yes. Thank you. 80. All right. So that's actually good that I did that. I wrote 100. I had it wrong. What did we say about using something that you find to find other things a couple weeks ago? Don't do it. How come?
Because you don't know if you're right.
Right. Even if you get the right answer in your head, even if somebody tells you the right answer, you might write down the wrong one. And if you do that, and you use it, then everything else is going to be wrong. And that worked fine a couple weeks ago. Unfortunately, we can't always do that this week. You are going to have to use things that you find to find other things. Particularly in this problem, you have to use gamma to get C. There's no way around it. So if you get gamma wrong, you're automatically going to get C wrong. But you could still get B right. Okay, gamma has nothing to do with B, but it has everything to do with C. Okay. All right, so we'll avoid using stuff if we can, but honestly, most of the time you can't. You have to use what you calculate. All right, let's find B first. Let's find B. For this problem, it really doesn't matter once you get gamma if you do B or C. Could do either one. I just chose B. So every time you set up the law of sines, you're going to have something like this. Now remember, you want as many of these spots to be numbers as you can. Specifically, you want 3 of them to be numbers. 1 of them will have a variable in it. So if I'm going to try to avoid having lots of variables, what row do you think I definitely want to use there?
First row.
Definitely want to use that first row. Not only was it given, which is good, there's no letters in it. Alpha is 40, A is 4. Plug those 2 numbers in right there. Alpha is 40, A is 4. Okay, let's do that. Sine 40 over 4. In fact, that sine 40 over 4, you're going to set it up like that to find B. You're going to set it up again like that to find C. Okay. Now on the other side, look at what we're trying to find, B. So now, you're going to use row B. So now you're going to fill in whatever you can into that fraction on the right. Sine of beta over B. Well, I know beta is 60. I don't know B. But that's okay. That's my one variable. Sine 60 over B. Now, what do I do to solve that? We talked about that. It's called a proportion. How do you solve it? You're going to cross multiply. So you're going to get 4 sine 60. I'm not even going to figure that out. I'm just going to leave it like that. Till the very end. Okay. Equals B sine 40. Right. So that's good. I don't have any fractions now, but I still want to get B by itself. Right. So I want to move that sine 40 to the other side. Okay. How would I move that over? Yep, divide by. Right, so I'm going to divide. What would I divide each side by to get B by itself?
Can you divide sine 40?
Yeah, divide by sine 40. Sine of 40 is just a number. Okay. If we really wanted to know what it is, I mean, it's 0.64, roughly. So it's like I'm dividing each side by 0.64. I'm not going to write 0.64 because that's not accurate. That's rounded. I'm just going to leave it as sine 40. Sine 40. Sine 40. That's gone. And now, we just type that into the calculator, and that's the answer for B. That's all gone. Don't try to reduce anything here. Just type it all in exactly the way you see it. Okay, so this is a good thing to practice on your calculator because if you're getting different answers than me, it could be the way you're typing it in, it could be parentheses, and I'll help you with it throughout the week, but not on the day of the test. All right. So, if you are doing it on your own, first thing you want to do is put it in degrees. How do I know that? Every problem here had a degree symbol on it. We won't be doing any radians this week. All right, so put it in degrees. Type in 4 sine 60. Now on my calculator, it's very important. I go like that. If I don't put that parenthesis in, it will come out wrong. Okay? Because I'm done with the top. Now, divide by sine 40. It's not really important that I put a parenthesis on the bottom because I'm not typing in anything else. I'm done. If you want to put it in, you can. But that's how I have to type it in. And if you tried it and you got 5.389 on your calculator, then you did it right. If you didn't get 5.389, then you are typing it in wrong. Any questions on how we got 5.389? Okay, so we've got 5 out of the 6 things. We need one more. We need C. Now, I know to get C, I'm definitely going to use row C. But I have a choice now. Whenever you use law of sines, you always have to use one of the rows that's full. I have 2 rows that are full. So, which row should I pick to use? Row A or row B?
A.
Why? Because it was given, right? Row B, even though I'm pretty sure I did it right, that's a rounded number. Don't use rounded numbers if you can avoid it. So let's use row A again. Find Z. In fact, if you want, you can do this every time, because that's how every problem is going to look. Now just fill it in. Sine of 40 over 4 equals, and what's going to go on the other side? Sine of what over what? Yep.
Sine of 80 over C.
Yep, very good. Sine of 80 over C. Now, I know 80 is a number we calculated. I have no choice. I have to use it. If you don't use it, you can't get C. So you have to use it. Now, when I did the cross multiplying last time, I did it all, very deliberate. I broke it all out. If you can do the cross multiplying in your head, that's fine, right? All that's going to end up happening is it's going to be this times this for sine 80. And then you would have to divide each side by sine 40, because you would have C sine 40. And you got to move that sine 40 to the other side. So after you cross multiply and get C by itself, that's what you end up with. Any questions on that? Okay, let's type it in and see what we get. Now, same rules apply here that always do to triangles. Any 2 sides added together have to be bigger than the third. So I know that side C is going to be smaller than one number. But the side C have to be smaller than, because if it came out bigger than this number, you wouldn't have a triangle. 9 point. Yeah, roughly 9.3, right? If this comes out bigger than 9.3, then these 2 sides added together wouldn't be bigger than it. That's a problem. So something's wrong. So we're hoping for a number that's smaller than 9.3. So let's see what we have. So we've got 4 sine 80 divided by sine 40. And I get 6.128. Now, let me type the same thing and show you what happens if I don't close the parenthesis. Unfortunately, the calculator is going to give you an answer. It's not going to give you an error, but it's not going to be 6.128. So if you write down 3.298, that's wrong. Okay? 6.128. All right? And your calculator might be a little different, but if you're getting 6.128, you're plugging it in correctly. All right. So when I'm done, I always check. Biggest side should be with the biggest angle. All right, looks good. Smallest side, is it with the smallest angle? Yep. And then any 2 sides added together should be bigger than the third. So if that was a question on the test, each one of those would be graded separate. Three separate answers. Okay. Any questions on that? Okay, so that was the angle side type. Now, this one you don't really have to draw a sketch to figure it out because the sketch is already there. kind of triangle is this one? Using the 3 letters like A's and S's. This is angle, side angle. If you go back and look at your notes, is angle, side angle one of the types that we use law of sines for? Yeah, angle, side angle is one of the types. Okay, so we can set it up right away. Remember, what's the other thing you can look for in the table that I said it's kind of a shortcut that tells you that it's law of sines?
Is it one full row?
One full row. Now, when I look at that, do I have a full row in that table? No, but do I have a way that I can get a full row before I have to use law of sines? Because if I can get a full row before I start law of sines, then I'm still okay.
Yeah, because gamma would be 95.
So we definitely can get gamma because we have 2 out of 3 of the angles. So we can just add them up and subtract from 180. So 45 and 40 gives me 85. Subtract that from 180. That's 95. Now you have a full row. That row is very important. It is the only row that has everything in it. So that means you are going to use this row to find everything. So why is it really important that you get gamma right in this one? It's even more important than the last problem.
Because that's what we're going to be basing like our A and B off of.
Okay. And what would happen if that's wrong?
Then everything would be wrong.
Then everything is wrong. Okay, so this problem, if you get gamma wrong, you get it all wrong. Okay, so you got to make sure you get gamma right. So just don't make a mistake with gamma. Just add them up and subtract from 180. All right, so now whether you find A or B first, it doesn't matter. It's just like the last problem. All right, so let's set it up to find Aiden, which one do you want to do first?
A.
A, all right. Can you set up the law of sines for me to find A?
Sine of 45.
Yep.
And A at the bottom.
A in the bottom. Okay, that's good. You get the left. Can somebody else set up the right side?
Sine 95 over 4.
Yep. Sine 95 over 4. Perfect. There's your proportion. And now let's get A by itself. You don't have to tell me the decimal, but can anybody tell me what A will be? It'll be what times what divided by what? Oh, Con? Not sure? Libby?
It's 4 sine 45 divided by sine 95.
Yes. Thank you. 4 sine 45 divided by sine 95. And now we type that in. Okay, before I type it in, I can scroll up and see if there's anything I might be able to think before I do it. Well, it's going to be the middle size side. I don't know how big that's going to end up being, but I know it's less than 4 because this is the biggest side, this is the biggest angle. So whatever I get here, it's got to be less than 4. Okay, but what you can't do, and this might be another pattern you look at, if you have an angle that's half as big as another angle, it does not mean that that side is half as big as the other side. Doesn't work that way. Okay, so let's see what we get. 4 sine 45 divided by sine 95.
That's weird.
Yep.
Why did you flip them?
because you cross multiply. So you've got 4 sine 45 equals a sine 95. But you've got to move that sine 95 over to the other side. Okay? You can write out that middle step if it helps when you cross multiply. What I just said, 4 sine 45 equals a sine 95. But I usually just jump right to the final part. You can write it out. Okay. So we get 2.839. Okay. Seems reasonable. Okay. So now I've got A and I've got C. I've got 2 out of 3 sides. Can I use Pythagorean theorem to get B? What do you think? Can I use Pythagorean theorem to get B?
Yeah.
No? Why?
Because you did work in Hager.
Okay, so it might not be the best idea because that number is rounded, but let's say I know for sure those numbers are right.
You can't do it because there's no 90.
There's no 90 in that problem. So if you use Pythagorean theorem, you're assuming that this angle is 90. Well, I can tell you that it's not. It's 95. So you'd get an answer that's close, because this angle is close to 90, but a close answer isn't a correct answer. So you can't use Pythagorean theorem to get B. You've got to do B the same way we just did A. Okay, so let's set it up to find B. Okay, same choice I had last time. 2 full rows of information. So how about Ben, given that I have 2 full rows, which one should I pick?
B,
Why?
because you don't have B yet.
Okay, well, I agree that I am going to use row B, but I have 2 full rows. So I have to choose which one of those to pick.
A.
Why?
I need C because it's like a nice number, I guess.
Okay, so yeah, they're nicer numbers. You wouldn't say this time because everything was given. No, we didn't have any row that was given. But they are nice numbers. So that's why I would go with C. All right, so we're going to have sine 95 over 4, just like we did here. Doesn't matter what side you put the sine 95 over 4 on. You're going to end up cross multiplying. So it'll work out the same. So let's put sine 95 over 4. And Ben said we're going to use row B because that's what we want to find. Sine 40 over B. Sine 40 over B. Right, now we'll cross multiply. So B is going to be 4 sine 40 divided by sine 95. Now, before I type that in and see what I get, what do I know about side B? Just looking at that information.
It's going to be the smallest.
It's going to be the smallest, so it should be a little smaller than 2.8, maybe 2.4, 2.5. I don't know. But whatever it comes out to, it's going to be the smallest. Right, so let's see what we get. Unless, does anyone already have that to 3 decimal places?
It's 2.581.
Thank you. 2.581. And that 3 decimal places that I've been using, that's pretty much what we'll do all week. Okay, so for homework test, just go to 3. So if you go to 3, even if you have to use one of these numbers that's rounded, you're not going to be that far off. Right? So if you were supposed to get like 2.581 and you got 2.6, that's pretty close. That's okay. If you got like 2.9 for B, that's more than a rounding error. Now you're getting kind of far from 2.5. All right. So you could be a little bit off, but if you're going to 3 decimal places, you shouldn't be that much off. Okay. So that's the angle side angle type. Questions on that one? Okay. The last type we're going to look at, and we're going to do more with tomorrow, is side-side angle. So you've got 2 sides, you've got an angle, but the angle that you know is not the one where the 2 sides meet. If it was, that would be side angle side, and that's law of cosines. but we've got the angle where they don't meet. So it's side-side angle. So this is the trickiest case out of every case we're going to learn all week, because when you go to solve this problem, three things could happen. It could end up being just a normal problem, like we've been doing all along. It has one answer. Or it could end up being the kind of problem where there are two answers for everything you don't know. Which doesn't really mean it's harder, it means it's longer. You have to do everything twice because there's two sets of answers. So when I say two sets of answers, that would be like you get two answers for A, two answers for B, two answers for gamma. That couldn't happen on this last problem. But it could on this one. And that's kind of the worst case because it takes longer. And then the best case is it's the kind of problem that you start to solve it and there's no solution. Meaning the information that they gave you, it is impossible to make a triangle. So we'll look at each one of them, but we're going to see which one we focus on first today in a minute. This only happens with side-side angle. Never happens with any of the other types we learned. Not going to happen with any of the types we learn on Wednesday. This is the only one right here. So we already have the diagram. So the diagram that I gave you up above, that is the diagram for this problem. So the way you can kind of tell by looking at the table, if you don't have a diagram, that this is the worst case, you have a row with everything in it. That means it's law of sines. You also have a row with nothing in it. And you have no way to get anything in that row. So if you've got a completely empty row and a completely full row, that's when it's law of. That's the worst case that we have to deal with. But again, if you don't remember it from the table, draw the sketch, and then you'll see it's side-side angle. Now, with side-side angle, you have to do things in a certain order. Out of the three things you don't know, beta, gamma, and C, you only have enough information to find one of them right now. Two of them you have to ignore. Does anyone think they know which one of the three we have a shot at figuring out, and the other two we can't even do anything with yet?
Beta?
Yes, beta. That has to be the first thing you try to find. If you even try to use the third row, you're going to run into a problem. You have two variables in the third row. That's no good. You have to pick two rows and have one variable. So if you pick the top row, good, no variables. If you pick the middle row, good, there's only one. If you pick the bottom row, there's two, no good. So you've got to pick the top two and set that up. Okay, so we are finding beta in this case. So we're going to start with sine 40 over 3. That's pretty much the same. Equals. What's going to go on the other side? Yep.
Sine beta over 2.
Yeah. Sine beta over 2. Now, that's a little different than any other calculation we've done today. Does anybody see what's different about it?
You have beta. Like, if you don't have beta, you have a number for B, but you don't have a number for beta.
Yeah, we don't have the angle, right? This is the only time that's ever happened where the angle is the letter. It's the variable, right? So we're still going to cross multiply, but let's see what happens as we do it. So we've got 2 sine 40 equals 3 sine beta. So I want to get beta by itself. There's two things that are preventing it from being alone. There's a 3 and there's the function sine. Well, we can get rid of what's farthest away. The way I think of it is, think of like beta, it's being protected by sine because it's right next to it. Right? The 3 is further away, so it can't protect it. So it's easier to get rid of it because it's further away from beta. How can we get rid of the 3 and put it on the other side? Yeah, divide by 3. So we can do that first. That's gone. That's gone. We still don't have beta by itself. Okay, but we're closer. So now we have 2 sine 40 divided by 3 equals sine beta. So sine is a function. Okay? It's not an arithmetic operation. So that means you cannot get rid of that with adding, subtracting, multiplying, and dividing. Sine is not arithmetic. It's a function. So to cancel out a function, you need another function that's the opposite of it. Okay? One example is like square root. If you want to get rid of square root, you can't add, subtract, multiply, or divide. You've got to square. Square and square root are opposite functions. What's the function that's the opposite of sine? Inverse. Inverse what? Yes. Inverse sine. So we are going to take the inverse sine. There is no multiplication there at all. Right? We're just taking the inverse sine of everything that's on the right, and we are taking the inverse sine of everything that's on the left. Inverse sine, regular sine, gone. And now we've got beta by itself on the right. Okay, so let me show you how you type all that in. So second sine, that's your inverse sine, 2 sine 40. Now, close the parenthesis for the argument to the sine function. You still have to do divided by 3. And now close the parenthesis again for the inverse sine. Now, when I hit enter, one of 2 things is going to happen. I'm either going to get an answer on the screen, in which case that means it's not a no solution, or I'm going to get an error. If I get an error, it means it's no solution. This is not a no solution problem. I just got an answer. 25.374. Okay, so that is an answer. Any questions on how I got that? So all I know at this point is it's not a no solution. So it could be a 2 solution, or maybe it's just a 1 solution. Is there a second answer for beta? That's what I need to find right now. And I'm going to show you how you find out if there's a second answer. It involves the number that you just found, 25.374. I have it written out right here. So to check if there is a second answer, take the answer that we just got and subtract it from 180. Okay, let's do that. 180 minus, we got 25.374. 154.626. I'm just going to write that off to the side. So take what we got for beta, subtract it from 180. Now, I'm not writing that in the box yet. I don't know if that answer works. What you have to do now is, after you do this calculation, see if it's possible to have the angle you just found, 154.626, and the angle that they gave you to start with in the same triangle. Now, when I say see if it's possible, what's the rule about angles in a triangle? They have to equal 180, all right? So let's see if it's possible to take the angle that we just found, which was 180 minus beta, and the given angle. Let's scroll back up and see what the given angle was. 40. That was the given. So the question is, can I fit 154.626 and 40 degrees in the same triangle? That's what I found for the second answer doing that calculation, and 40 was the given. Would they fit in the same triangle? No? How come?
It adds to like 190 something.
Yeah, 154 and 40 adds up to 194. That's too big. So in this case, the calculation that I did to get the second answer, we didn't do it wrong. It's just in this case, it came out too big. So I don't need the second answer in this problem. Now, if the second answer had come out to like 110, then I would say, okay, 110 and 40, could I fit them in the same triangle? Yes, because that only adds up to 150. And then I would have written that second answer, 110, right here. Okay, but 154.626, it's too big. So any question on how I found the second answer, and then the second part, how I figured out it didn't work? Okay, now that we know it doesn't work, you don't have to worry about a second answer anywhere. This is going to be a normal problem from here. If this has one answer, this has one answer, this has one answer. If this had two, this has two, this has two, they're all two, or they're all one, or if beta came out to no solution, then gamma would be no solution, and C would be no solution. All you have to worry about is what you're trying to find. Don't ever worry about the stuff they gave you. The stuff they gave you is done. All right. So now we know beta. What could I get now? I have enough information to find something else. Gamma. I can't get C yet, but I do have enough information to get gamma. And how would I get that, Libby?
You add alpha and beta together and subtract from 180.
So I get 65.374 when I add them up. Subtract it from 180. And I get 114.626. Now I finally have a piece of information in the last row. It's not empty anymore. And that piece of information for gamma will allow me to find what?
C.
C. And that's always the order you have to do it in. All right. So to find C, pick a row that has everything in it. I would go with the top row. So sine 40 over A. You know what? Let's put it over here. Find C. Sine 40 over A equals, and you have to use that 114.626 over C. And if you say, well, it's rounded, is that going to be bad? If you round to 3 decimal places, it's not going to mess up the answer for C that much. So if C is supposed to be 4.7 and you get 4.65, I mean, you're not that far off. Okay? So let's see what we got. We're going to have, A we know, sorry. A is 3. All right, so we're going to have 3 sine 114.626 divided by sine 40. Okay, before I type it in, what do I know it's got to be less than? It's got to be less than 5 because any two sides added together have to be bigger than the third. So I know it's less than 5, but it's got to be bigger than what?
Both the A and B.
It's across from the biggest angle, so it's got to be the biggest side. So it's got to be bigger than 3, and it has to be less than 5. So that gives me a pretty good range on what it's going to come out to. Right, let's see. If you don't get an answer between 3 and 5, you did something wrong. 3 sine 114.626 divided by sine 40. It's exactly what we thought it should be between. And we got 4.243. And now we've got all the information. Okay, so that's the trickiest case because you got to deal with that 1 solution, 2 solution, no solution. Tomorrow we'll go over the homework. We can practice another one of those if we want. And then we're going to look at the 2 solution and the no solution and maybe a word problem. Probably a word problem or 2. All right, so homework tonight, it's all odds. 9 through 13. 17 through 21, and 25.